Okay, maybe I'll just go through, I'll run you through this part B before we reach part C. Okay, I'll just explain to you what these terms are. So, a cash discount, this is where you are trying to make people pay fast. If you sell goods on credit, okay, sometimes you don't know how long it will take the person to pay you back. So, one way to entice them to pay you back is to say, okay, the money that you're owing me, I will give you a discount. Just pay me within one week or maybe within 2 days. So if the person is owing you 5,000, okay, say, okay, I'll give you a 10% discount, so that if you pay me within 1 week or 3 days, so that you entice the person. Oh, instead of paying this person 5,000, I've got a discount, so I'm paying him 4,000. What is 10% of 5,000? It's 500 kwacha, I believe. So the person's paying you 4,000. Anyway, they're paying you 4,950 somewhere there. They're paying you less, basically. Okay, that's a cash discount. You want the person to pay you faster, and to entice them, you tell them you give them a discount. Are we okay with that, colleagues? Any questions on a cash discount? Then a trade discount. This is where you're trying to promote bulk buying. Okay, you want someone to entice people to buy in bulk. I believe we've experienced both kinds of discounts, both cash and trade discounts. So when you buy in bulk, you're given a discount. Or if you're owing someone, they tell you, pay me quickly and I'll give you a discount. That is the difference between a cash and a trade discount. Any questions? Cash discount, you want people to pay you fast. Trade discount, you want people to buy in bulk. IRR and NPV, these are techniques used to decide what to invest in. Okay, techniques used to decide in what to invest in. Okay, now it's going to take me long to explain how these techniques work, so I'll give you notes on them, but just know that these are techniques used for deciding on what to invest in. These are techniques companies use. Okay, the internal rate of return, what it's going to basically tell you is the money that you're going to receive from your investment. It's giving you, it's giving it to you in a percentage format. Okay, because as a business, when you invest in something like machinery, new buildings, okay, you expect that investment to bring you money. Okay, so now you have to forecast, you have to predict, okay, this investment might bring me this amount of money in year one, in year two, year three, year four. Okay, you have to forecast the money that you're going to get from these investments. Then, after you're done forecasting that, the money that you're going to receive in these investments, you're going to have to now convert that money in the future into today's value. Okay, Colleagues, did you know that there is a way to convert money that you receive into in the future into today's value? Did we know that, colleagues? So with these techniques, the NPV and the IRR, okay, you are going to focus and say, okay, we'll make this amount of money in the future. Now that money in the future, you're going to convert it into today's value. Once you convert it into today's value, the net present value technique, you're going to compare your cash inflows, that money which you forecasted in the future, which you've converted into today's values. You're going to compare it against the cost of the investment. Basically, cash outflow minus cash inflows. Okay. And then it will give you a value, either a positive value or a negative value. So if you get a positive value, then it means the investment is worthwhile. You can go ahead and invest it. If you get a negative value, it means do not invest because you're going to make, it's like you're going to make a loss in your investment. That's what the net present value technique does. Then the IRR, the internal rate of return, though that money in the future that you're going to receive, you're going to convert it into a percentage. That percentage will represent your return. So this will be illustrated. There's a question further in this assignment which deals with these two things. So we are going to see what I'm talking about. But for now, just remember there are techniques in which businesses use to decide on what to invest in. Okay? That's what you need to remember. Okay, we can now come to the interesting part. We've got this question here. This is, we have to convert this expression here as partial fractions. So basically, when you see we're talking about partial fractions, it just means you're breaking down a fraction into smaller fractions. Okay, that's the concept here, colleagues. You're breaking down a fraction into smaller fractions. Okay, that's what's going to be happening here. Now, there's some certain steps that you need to do. Okay, step one, determine if the fraction is improper or not. Then let me type this out. Oh, please take down these steps, okay, so that in case this comes, you know how to you attempt it. So step one, are you able to see my words? Do I need to zoom in? So step one, okay, so determine if the fraction is improper or proper. How do we do this? You look at the leading exponents for the numerator and the denominator. Okay. So when I say the leading exponents here, our numerator, the leading exponent is x to the power 3. This 3x is our leading exponent, this 3 for our numerator. For our denominator, the leading exponent is this 2 here, this x to the power 2. Okay, that's the exponent you're going to look at. You're going to compare the exponent for the numerator and the denominator. Okay. So listen carefully. If the exponent, let me be typing this down. If the exponent for the numerator is greater than or equal to exponent of denominator, you have an improper fraction. Colleagues, remember from grade 1, grade 2, an improper fraction where the numerator is greater than the denominator. Now in this case here, we're looking at the exponents and we're taking that, okay, that's the numerator for that's the exponent for the numerator compared with the exponent for the denominator. Okay. So if the exponent for the numerator is greater than the exponent for the denominator, you have an improper fraction. And you need to do long division. Okay, division of polynomials. But if the exponent for the numerator is less than the exponent for the denominator, then you have a proper fraction. Let me type that. Sorry. So write this down. Okay. If the exponent for the numerator is greater than for the denominator, greater than or equal to the exponent of the denominator, you have an improper fraction. And when you have an improper fraction, you have to do long division. Okay. But if it's vice versa, exponent for numerator is less than the one for the denominator, then you have a proper fraction. So in this case for our question here, the exponent for the numerator, okay, you only look at taking note of the first exponents. Ignore the other exponents here. So if you see those, the other exponents, just ignore, just look at the first ones. So here, the exponent for the numerator is greater than for the denominator. So we have an improper fraction. So we need to do long division. Step 2, now we're going to do the long division. Okay. You put the denominator outside, x squared plus 3x plus 2 divided by the numerator. You put it inside this sign. Okay, it's the one that's being divided, it's the dividend. Okay, so x cubed minus, actually plus 0x squared plus also the next one is x to the power 1, so now it's minus 2x plus 0. Okay, now when you put the expression in this sign here, you're going to have to put it in descending order. Have you seen x cubed x squared x to the power 1. Okay. I know our equation was given to us like this: x cubed minus 2x. Okay. But when you're doing long division of polynomials, you have to put them in ascending order here. Okay. So since there was no x squared in this expression, that's why I've put plus 0x squared here. Then this minus 2x comes, then plus 0 there. Okay. Any questions? Any questions, colleagues? Okay. So you put the expression in descending order. Okay. So that you can easily divide. Because when if you miss this descending order, for example, if you miss this 0x squared, you're going to see as the process goes, there will be a point where you can't subtract anymore. Okay. Yes. So we're going to begin the division. Now remember, the process is just simple: divide, multiply, subtract. That's the process that's going to be going on here. Divide, multiply, subtract. Divide, multiply, subtract. So what are we dividing? You get the first term here, this x cubed. You're going to divide it with this x squared. So x cubed divided by x squared. You're going to get x. Okay. We've done step 1, divide. So this x, you put it here. Step 2, multiply. What are we multiplying? We're going to say x multiplied by x squared, x cubed. X multiplied by 3x, 3x squared. So if you did not include this 0x squared, the time we're going to be subtracting, you'll find you'll be unable to subtract with this 3x squared here. Then x multiplied by 2, you get positive 2x. Okay. Divide, we've divided. Multiply, we've multiplied. Step 3, subtract. What are we subtracting? This top expression minus this bottom expression. So this is the part where you need to be careful, because especially when there are negatives in this bottom expression, you have to be careful. So it's x cubed minus x cubed, 0x cubed. So you just leave it like that. Okay. They cancel each other out basically. And the next one, 0x squared minus 3x squared, you get negative 3x squared. The next one, negative 2x minus 2. Okay, we get negative 4x, right? Negative 2x minus 2x, you get negative 4x. Okay, this is 0, you can bring it down. Okay, we are done with the first cycle. Before we go to the next cycle, questions? Okay, the next cycle we start the process again: divide, multiply, subtract. So what are we dividing? Again, you're always just dividing the leading term within this division house, basically. You don't know what to call this thing for division here. This division house, basically. Okay. So this negative 3x squared here, okay, you are dividing it with x squared here, okay. So you say negative 3x squared divided by x squared, excuse me, you get negative 3. So you put here minus 3. So we've done the division. Step 2, multiplication. So you're going to say negative 3 times x squared, negative 3x squared. Negative 3 times 3x, you get negative 9x. Then negative 3 times 2, you get negative 6. And that's why this 0 was added here. Because eventually you're going to reach a point where you have to, there will be a number without any variables. So we've done the multiplication. Next thing we need to do, we need to subtract. So as I said, this is the part where you have to be careful because of these negative signs. Negative 3x squared minus negative 3x squared. Remember, negative and negative make positive. So it's like negative 3x squared plus 3x squared, you get 0x squared. Okay, this negative and negative make positive, then they cancel each other out. Then we've got negative 4x minus negative 9x. Again, this is negative and negative make it positive. So it's like negative 4x plus 9x, you get positive 5x. Then you have 0 minus negative 6. Negative and negative make positive, so it's the same as 0 plus 6, you get positive 6. Now, colleagues, the cycle stops when whatever expression you have, if the power is less than this one here, since this is x to the power 2 and this is x to the power 1, okay, we can't, since this x to the power 1 is less, so we can't proceed, okay, we can't proceed. So we end here, okay. If this was an x to the power 2, we would have continued, okay, but since now it's x to the power 1, okay, you can't now divide x divided by x squared. Okay, you can still, mathematically you can do it, but with long division for polynomials. You should never have a situation where your numerator has got a lower exponent than the denominator. Yes? Yes. Yes. You're only dividing the x squared, and you'll be dividing it by the leading terms in this. I don't know what to call this thing, this division thing, but as you've noticed, we divided this x squared with this x cubed, then we also divided it with this negative 3x squared. So it's like the first terms, you're only dividing the first terms in each equation. Um, So this is our remainder here. The remainder, okay? Remainder 5x plus 6. So before I go further, any questions? Okay, so now we're going to put our expression like this. Okay, so we have, yes, x minus, so this expression, I'm going to write it again. So x minus, put it here, x cubed minus 2x equals x squared plus 3x plus 2 equals x minus 3. Okay, this x minus 3 is this what we got on top here. Okay, this x minus 3 is what I've brought here. X minus 3 plus our remainder 5x plus 6 over. So your remainder, you're going to put it over there, this denominator here, which we said x squared plus 3x plus 2. X squared plus 3x plus 2. Now, colleagues, we are not yet done. Okay, you might have thought, okay, we're done here. We've made it two partial fractions. No, 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 no. We are not yet done here. Because now the one that needs to be broken down into simpler fractions is this. Okay, this needs to be broken down into simpler fractions. Okay, so first thing, before you break this down into simpler fractions, this denominator, we need to also simplify it. Okay, this x squared plus 3x plus 2. We need to simplify it, to break it into smaller components. Okay, so this is a quadratic equation. Let's solve this quadratic equation. Let's solve this quadratic. When we solve this quadratic equation, what do we get? We're not using any formula here. We're just solving it. We're solving it. We're simplifying it. There's no formula used. Yes. ah, don't rush. No, no, no surprise formula will appear. So I know the question in your minds, how many marks is this? Colleagues, this one, since there are two, you see it as, I think, 5 marks, 5 marks each. You might see it as 10 marks. If you see it as 10 marks, go for it. Okay. But if it's 5 marks, then first look for better questions to attempt first. Yes, has anyone simplified this quadratic equation here? Yeah, yeah, yes. Hmm, they're not here. Alright. Okay. Has someone solved this quadratic equation? Yes. What have you got? Uh-huh. Yes. Okay, just put it like this. I just want it in this in the factorized form. X plus what you got x plus one. Mhm. Yes. Are we all getting this, colleagues? Are we all getting this? X plus one over x plus two. Uh-huh. Yes. Yes. Yes, yes. It's the one which we used to break this down. Okay. Because remember, this 5x plus 6 over x plus 1 plus x plus 2, we need to simplify it into simpler fractions, basically. All right. So this is the shortcut method which I'm doing here. Okay, the long cut method. Oh, it's it's at night. We'll have more people logging out. Okay. So with this shortcut method, since you know that okay, this is the one that I need to decompose into partial fractions. Okay. So what you're going to do is this. It's a 5x plus 6 over x plus 1 x plus 2 equals. So this, since we need to simplify it into smaller fractions, so you're going to put a over x plus 1 plus b over x plus 2. So here what's going to happen is we need to find the value of a and of b so that we get the simplified fractions from this big fraction. This big fraction is being broken down into these two smaller fractions. Okay, but we don't know the value of a and we don't know the value of b. Okay, so we need to find the values of a and b. So how do we do that? This is how we do it. Okay, first things first, we need to get rid of these denominators. So what you do on the left hand side, we do it on the right hand side. So how do we get rid of these denominators? We're going to multiply the left hand side by x plus 1 multiplied by x plus 2, so that these cancel each other out, these cancel each other out. And we'll do the same on the right hand side. Meaning this a over x plus 1 multiplied by x plus 1, x plus 2, this x plus 1 cancels, remain with a times x plus 2. Plus this b over x plus 2, we're multiplying it by the same x plus 1 times x plus 2. So for b, the x plus 2 cancels with this x plus 2, so remain with b x plus 1. Any questions? Any questions, colleagues? Are we okay with how we've got the ax plus 2, bx plus 1? We've multiplied both of these fractions with this x plus 1, x plus 2. Okay, when we multiply a over x plus 1 times this expression, the x plus 1's cancel. So you remain with a times x plus 2. When you multiply b over x plus 2 times this expression, x plus 2's cancel, and you remain with b times x plus 1. Okay, so there are many ways you can now solve from here. Okay, you can expand the brackets and equate coefficients, or you can make life easy and say, okay, how can I eliminate each variable and find the value of the other variable? So if we need to eliminate a, what do we need to equate x to? Basic saying, what will make this -2? Yeah, so it's a let x equals -2. Now you only do this when you've got just simple x's like this. If you've got a quadratic equation in here or a polynomial equation, then you have to do the long route where you expand, then you equate coefficients. Okay, and you find that that method you have to form now a simultaneous equation. Ish, this topic. makes people cry. Ah, eh, okay. Not what I'll give you practice questions so that because with this one, there's a lot that's happened in this equation. First, we divided. Now here we're trying to get value. Yeah, so it's a long process. So we'll do some practice questions so that so say let x equal -2. Okay, so wherever there's an x, you substitute it with -2. So we start on our left hand side, 5, open brackets. We want to get rid of one variable so we can find the other variable. So to get rid of a, equate x to -2. Yes. So 5 times -2 plus 6 on our left hand side. Here we have a, open brackets, -2 plus 2 plus b, open brackets, -2 plus 1. Okay. So 5 times -2, that is -10. -10 plus 6 here on our left hand side, it will give us -4. Okay. Here, -2 plus 2, that is 0. 0 times a has been eliminated. Okay, we remain with b, -2 plus 1, that is -1. A times 0, this goes. B times -1, -b. So to get our value of b, we just multiply both, since both sides are negative here. Or if, since we want to make our b positive, because you never want your variable to remain negative. So we multiply both sides by -1, that our b becomes positive. So b equals 4. Okay, now we've got our b variable. We want to get our a variable. So we rewrite our expression again here. 5x plus 6 equals a x plus 2 plus b x plus 1. So in order to get rid of the b variable, what do we need to equate x to? What value of x can make this x plus 1 become 0 here, basically? Yes, so you say let x equal to -1. So here we have 5 multiplied by -1 plus, yes, you can replace it, but to be a long process, so you find yourself in simultaneous equations or more quadratic equations. basically you find yourself lost. Okay. So when we have time, I'll show you the other ways to do this. Okay. Here, it's just because it's night time, so it's best I show you the shortcut and the fastest way. Okay. In the exam, you can use this shortcut. You won't be penalized. You won't be penalized. Yes. So, sir, this way you're going to see it's faster. Okay. So here we have a where there's x, replace it with -1 plus 2 plus b, replace x with -1 plus 1. -1 plus 2, that is 1. So we have here a times 1 plus, for b, -1 plus 1, that is 0. So b times 0, the b goes. Okay. On our left hand side, 5 times -1, that is -5, plus 6. So -5 plus 6, that is 1. A times 1, that is a. So a equals 1. Okay, so you only use this technique when you see I've got linear factors like this, the x plus 1, x plus x minus whatever. Okay. But sometimes the conditions of the equations, especially if you've got quadratics, because in the quadratic equation there's usually a variable that doesn't have an x, so it would be hard to use this. Okay, so this is only used when in this situation here. So we write our proper expression here now. Okay, x minus 3 plus, okay, so here this 5x, this it breaks down into this a over x plus 1, b over x plus 2. So since we've got our values of a and b, a is 1, so it's a plus 1 over x plus 1 plus, we found the value of b, which is 4, 4 over x plus 2. Okay. So this is how your answer should be. Yes. 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 In short, what we've done here is this expression has been broken down into this. That's what the question wanted. When they say into partial fractions, yes. In your spare time, you can try to. Mm-hmm. Uh-huh. Mhm. Or what you're asking is there's no way to skip the long division and just come to this process here. Unfortunately, unfortunately, no. Mhm. Yes, first, because usually with this question you'll be given an improper fraction. So once you see it's an improper fraction, then you need to first do the actual division of these two here, which we did this polynomial division here. Once you've done the division, have you seen? You find now it broke down into x minus 3, which is here. Then we have our remainder, 5x plus 6. And always remember, the remainder, always put it over the denominator. Yes, yes, yes. The answer, no, the answer you have to now break down this remainder over this denominator. You have to break it down further. Basically, we're moving backwards, okay? It's like we're moving backwards. Because if you do this x minus 3 plus 1 over x plus 1 plus 4 by x plus 2, you're supposed to get this answer here, which is on the left hand side. Yes, so now here we're moving backwards. We're moving in reverse now. Yeah. Okay. Yeah, that's why they